Okay, so I will be explaining this code which will be used for our lab 6 task. So for this part, this is task A, and this is the code of for questions 1A and 1B. Okay, this function ZA, this will declare a new custom function named ZTransfer, and it will take two inputs, sequence and n, and outputs the result at ZA. Z equals to poly bracket 0 ZR. This defines the mathematical variable Z as a polynomial. R specifies that 0 is the root of the polynomial, and Z is the symbolic variable for the equation. Below here, ZA equals to sequence times 1 per Z power of n. This is the core calculation. This multiplies the input sequence array by Z power of negative n. And this symbol here transpose the array from row to a column. So below here is to execute the code. Here x1 it is define the specific discrete time sequence that we want to transform. So we put here as 1, -3, 4, 5, 0, 1, which follows the numbers given in the question, and n equals to 0 length x1 minus 1. This creates a time index vector n matching the sequence. It will start at 0 and goes up to the length of x1 minus 1. And below here is z transfer x1 and n. This will call the custom function defined just now, and it will pass the sequence and n into the function, perform the math, and then store the final result in ZZ. So when we run this, the same will be done for task 1B. But if we look at the question here, it is given that 1, -1, 2, and 5. But here is stated that n equals to 2, 3, 4. So that means when we input the data for x1, it should be 1, -1, 2, 2, 2, and 5. That, that means that all the values for the second for 2, 3, 4, all should be written as 2. So when we run this code and open the console, okay, next for task B, write a Scilab program to compute the inverse the Z transform and generate the pole 0 plot of the Z transform. Okay, so for these three questions, we will use this code. Okay, first we will set the parameters, and this Z equals to percentage Z. This defines Z as the symbolic polynomial variable. And A, we will put this side, which is called the numerator, and B the denominator. So A, we will put, according to this question, we will put 2 times Z power of 3, because we cannot just put 2 Z power of 3 just like that. We need to put this star to indicate that this is a multiply of 2 with Z power of 3 plus Z multiplied Z power of 2 minus 8 multiplied by Z plus 3. And B, we will put the denominator, which is Z power of 3 minus 1. This is power of 3, because if you put power of 2, it will not generate the graph. And then L equals to LDIV, which means the polynomial long division. Then below this, this is display. It will print the resulting sequence array L to the console. Then below it, xz equals to a divided by b. This creates the rational polynomial transfer function. Zpk equals to tf2zp xz. It converts the transfer function tf into the zero pole range, which is written as zp. It outputs the 0 into an array z, the poles into p, and the system gain into k. And then this display zeros will print the zeros to the console, and it also prints the poles for here. Display poles. It will print the pole to the console as well. So below here, figure 0 creates the new graphic window labeled figure 0, and then the PLZRXZ, it plots the poles as x and zeros as 0, as O on the complex plane, and x title will be a pole 0 plot. So when we run this code, this is what will it generate. And for B and C are the same. We just have to change the numerator and the denominator right here according to the question.